Hello and welcome to Grade 9 Applied Math. We're in Unit 7, which is Data Management with Linear Relationships. And today we're in Lesson 2, Creating Scatter Plots. So our learning goal today is to, by the end of the lesson, to select an appropriate scale for the scatter plot, create scatter plots by hand, and investigate the relationship between two variables. Now, some theory behind this all. So you can graph data on a scatter plot if the data has two numerical variables, like a x and y coordinate. Plot the independent variable on the x-axis, the horizontal axis. So the horizontal axis is the x-axis. Two numerical, we want to have x and y coordinates. And the plot the dependent variable on the vertical axis, the y-axis. Choosing a scale is very important. Two important questions. Should my scale have a break in the axis? Okay, so sometimes you'll see a scale like this, where at the beginning they do a break. Okay, and so these are called a break. And this is if you use a break if you need to skip. So if you have nothing, for the first 100 numbers, and then all of a sudden all your information is between, a very narrow group, then you'll want to have a break. If it spreads nicely from 0 to numbers up to a certain point that makes sense, then you could keep the 0. And then the next thing is, what interval should I be using? How much should I be going by every grid, on every grid line? So these are tough things to decide. You have to look at the range. So you must do this separately for each variable. So you're not going to get the same variables along the x-axis and along the y. They're going to be different. Here are some guidelines. So to use a break or not, I personally prefer not to use a break if I don't have to. So, but here are some ways to decide. To determine if a break is needed, first calculate the range. So what is your largest value minus your smallest value? Okay, compare the range to your smallest value. If the range is less than or equal to that of your smallest value, a break would be a good idea. If your range is greater than the smallest value, a break is not likely. Okay, so good to know. All right, determine what your intervals should be. Well, um, there's a break. If you have a break, then count the number of squares you have on your graph, on your grid. Subtract one square. You'll need room to draw a break symbol. So that's where the break is going to go in the first grid. Divide your range by the number and round up to the nearest multiple of 2, 5, or 10. You want to have nice numbers, depending on how large your numbers are. Now, if you don't use a break, if you're going from 0 and up, then count the number of squares you have to work with and divide the largest value by this number and round up to the nearest multiple. So 2, 5, or 10, depending on how large the numbers go up. Okay, so in other words, how are we going to determine a range here? So the range, in this case, is the highest I think we can find is a max of 75 and a minimum of 47. Okay, and this is for the range of length. So we're looking at constructing a scatter plot for the wingspan, data for bird's length for 12 birds below. So we're thinking that a bird is longer if its wingspan is longer. If its wingspan is long, then it's probably a longer bird also. Okay, so for a range of length, we have a top number. Oh, actually, 78 was larger. 78 minus 47 is 31. Okay, so we asked ourselves, when do we need a break? Well, it said, compare if the range is less than or equal to that to then your smallest value, then a break would be a good idea. So the range is only 31, so it's much less than 47. Okay, so 31 is less than 47, so break is a good idea. Okay, so yes, break. So what that means is on our grid, we build. Actually, sorry, length is on the other side. We build a break. Okay, there's our break. All right, next we try wingspan. Okay, so find the range. Our highest number looks to be 222. Our lowest number looks like 71. Okay, so 22 minus 71 equals 151. Okay, it is greater than our lowest number. Okay, so a break is not a good idea in this case because it's greater than. Okay, so 151 is greater than 71, so no break. So of course, this is the x-axis, this is the y, this is the y, this is the x. Okay, now we have to ask ourselves, how many squares do we have? Well, along the x-axis, we have 1, 2, 3, 4, 5. Again, count starting at this one. Don't count the break because that break is taking up space. And both of these start at 0, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have a range of 15. So, sorry, we're back up here. Length, we have a range of 31 divided by 15 squares. So this isn't great because 31 divided by 15 well, it's a range, so is 2.07. So we're just outside the 2. So I think we're going to have to change that. So what if we went up to, we said we should round by 2s and 5s. You can almost go up to 4, but let's go by 5s then, all right? So now the thing is we start at the lowest. What's the lowest one we're starting at? We're starting at 47, okay? So we don't want to start at 47. We want to start below 47. So let's start at, let's do even numbers, right? So we want to start at 46. We want to go every, you know what, if we're going to go by 5s, okay, go by 5s. All right, so if we went by 5s, because 2 just didn't work out too bad. So if we start at 45, then we go 50. Now I'm not going to write the 50 because I'm going to get too crowded here. Well, I'll write 50 and then I'll go up by 10s. 60, 70, 80. Yeah, it would have been nice if we even went by 4s or something like that, but yeah. Well, we could do that. Okay, let's start again. Let's go by You can see there's no exact way to do this. It's very, very difficult. Okay, so if we start at 46, we could go to 50, 54, 58, 62, and I'm happy to show you like these. It doesn't always work out uh, perfectly. It's difficult. I think I made a mistake there. So 54, 58, 62, 66. No, I think I'm okay actually. 66. Maybe we're not going to have enough room. Right. Okay, we're going to have to re-scrap all this. Okay, so let's try going by fours, and we'll start at 46. But every grid is 4, so every 2 grids is actually 8. So this would be 50 and then 54. What would be another 8? Would be 62. Another 8 would be 70. Another 8 would be 78. And actually, that's going to get us to where our top number. 78. Another 8 is 86. And we could probably stop here, but 94. Okay. Um, let's just double check we made that done properly. Yeah, that looks good. Okay, along the other side. Okay, I think we were using kind of like red for this. So now we should have 16 grid lines, and we have a range of 151. So 151 divided by 16. Okay, 151 divided by 16, and we're starting at 0 for this one. So actually not our range. That's a mistake. Not our range. We want to go to our max, 222. 222 222 divided by 16 is 13.9. Okay, well, we're not going to jump up by 14 every time. So what should we do? We could go by 30s. 15, sorry, we could go by 15. So we could go by 15 interval. You could go by 20 if you wanted. Maybe that's what we should do. It'll be a little simpler. 15. Well, 15 would be all right, but we'd actually skip every 2 would be 30. But let's go by 20s. It said to make it easy on yourself. So 0. If every grid line is 20, then we have 40, 60, 80. We have another 40 is 120, 160, 200. Let me make sure we're not making a mistake here. 40, 80, 120, 160, 200, 240. Okay, so every line was, so in other words, did we use 12 lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, 12. Okay, good. Now we can start. Now, once we've done this, now we can start to plot the points. And this takes some time. So what are we going to use? Different color. We'll use purple here. All right. So we have to go point by point. So first one at 56, and 56 and 120. Okay, there I got that point. At 65, we're thinking 65 is around here. 65 and 110. All right. 78 and 222. So 78 and 2, there's 78 and 220. Just over that line. 75, and so pretty much in between. It's 74 is here. So 75 and 128. 75 and 128. There we go. 48 and 71. 62 and 75. 48 and 86. 48 and 86. And 47 and 100. Oh, that 100 would be right in between. Very good. Okay. 52 and 100. So 52 and 100. 51 and 120. 55 and 127. 70 and 150. Okay, so we see a trend. It's not, we might argue that based on last time, you might say, okay, what kind of oval do I have? Right? Based on that, I could say, okay, well, I have a weak, positive, correlation. Now, don't get me wrong, it didn't ask us this, but I just want to build on last lesson and strengthen that idea. Okay. One thing we forgot to do was put in our axis name. So wingspan, centimeters. We had, now this is not going to fit, but we had length. And you would never write it on here. You'd write it below the numbers, but ran out of space here. Okay, so we have wingspan versus length of a bird. Very good. So that's all we have today is to try and just define again, what is a range? What is the range? What does the range tell us to do with using a break or not a break? And if we want to, what our scaling should be. And this is the trickiest thing. So if you want to stick around, I'll show you you can go, but if you want to stick around, I'll show you a way to use Desmos to help you with this. So why don't we go ahead and do one of these practice questions where they give us lots of numbers. This is more than we bargained for, but okay, I have a lesson up here from grade 10. You guys don't have to worry about parabolas. So um, if you want to follow along, you can. So we have a very useful tool for you going forward if you can use Desmos well. So look what I'm going to do on this side. Okay, I'm going to go to this plus sign and I'm going to press plus and add a table. So in this table, I have to now put in all this information. So I have 25, 30. If you want to pause the video, open up Desmos and see if you can follow along and practice this. And I would use Desmos. You can use Desmos on your phone. You can use it on a tablet like I'm using, on a laptop with an open um, tab. So we just keep going, 37, 38, 40, 41, 45, 55, 60, 62, 65, 70, and 75. I'll work myself back up. 37 for 5, 0, 0, 37, 0, 0, 0, 43, 0, 0, 0. Now you can see how we don't want to map all these. Like these are big numbers. So coming up with a scale is going to be tricky. So 42500. Okay. 41000, 41000, 36000. Just double check. I'm at 41 and 3500. Good. 40 and 32,000. Oh, mistake there. Remember outlier. You could form an outlier if you get the wrong number. 30,000 and 29,000. 35 is 29,500. Where are we at? 30 is 26,500 and 22,000. Okay, we have all our data now. So let's see what this will look like in our scatter plot. We have to zoom way out. All right, that's where we found our first one. Is that right? Somehow do I have a 0 somewhere? That's very strange. Why do I have that? Did I have a 0 somewhere? Or it's counting as 25. Oh, yeah, this is going to be really, I'm going to show you something strange here. Look how jam-packed these are. Okay, well, that's not cool. So I'll show you a very important trick. Go to your tool, your wrench, and decide like what's our lowest and highest number. So along the x-axis, what's our lowest and highest number? Our highest number goes up to 75. So I can change this. Now on the negative side, I don't really need much negative, but I'm going to ask you to put at least like 5 so that you have some space. The other thing we're going to say is, remember that our x-axis is the age. Okay, so we're going to name it age. On our y-axis, oh, now our highest number is 75, but let's give ourselves some extra space. So we'll give us up to 80. Okay, now on the y-axis, okay, we're calling this earnings on the y-axis, and earnings depend on the age. Earnings. Now, let's give ourselves some space. Now, if we jam it to -5, it's not going to be enough. So maybe give yourself 10. We'll see how that works. And then on this side, what's the highest number we go up to on earnings? So scanning your chart here, we see it peaks at 43. So what if we made it 45,000? Okay. And I just noticed a problem right here. Just lost the 0 there. Okay. So now we see our scatter plot. Oh, there we go. There it is. Right, we can expand this if we wanted to. It looked nice. If we did that. Okay, so we see an upward trend of this data. Now, why did I say why would you want to do this? Well, it kind of gives us an idea that if we went up every 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, we'd have, well, we need 20. So that actually doesn't work very well. So, but if we went up, well, you could also say, do you need a break? And so if this was a break and you started at 20,000, you go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 5, and you'd be using up your 16 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's build in a break. Okay, so we need a break here. And I probably wouldn't need a break on this one. So how do we go up? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's easily 16. So if every 4 was 20, 1, 2, 3, 4, 20, 1, 2, 3, 4, 40, 1, 2, 3, 4, 60, 1, 2, 3, 4, 80. Okay, so at 20, 40, 60, 80. And yeah, I don't know if we go over 80. Is there any? No, there's no over 80. So that's good. Now, we said we'd go by 5s. 1, 2, 3, 4, 5. But we'd start at 20,000. So 20,000. thousand. And then 1, 2, 3, 4, 5, 30,000. And then 1, 2, 3, 4, 5, 40,000. 1, 2, 3, 4, 5, 50,000. Okay, so at 20, 30, 1, 2, 3. Oops, I'm a little bit ahead of 1, 2, 3, 4, 5. There. And then we could grab, I'm not going to grid these, so that would take quite a long time, but basically, our points would be a lot like the ones we have here, 20, and really starting around 20, we get some numbers like this. Okay, so we see these numbers like that. Obviously, I'm not doing it that accurately, but okay, so we'd have that same sort of trend. Anyways, I'd like to do it more perfectly, but I know this video's gone long. But I'd be okay with you using this graph. I mean, it's a skill to graph, but under you want to use it to double check. So if we were to ask some questions here, describe the relationship. Well, it's pretty strong and pretty positive. So strong and positive correlation. Is the relationship between age and the amount of money you earn? Is there a relationship? Yes. If so, describe it. Okay, well, as one ages, their earnings increase. Right. Think of your parents. Think of when they started working as young adults and to where they are now, their salaries may have gone up. Are there outliers? Okay, well, that's a great question. Do you think there's some outliers? Perhaps. At this later age, if you look over on this graph on the left, I don't think I can use but these outliers at age 70 and 75. Sure, there's outliers, right? These two outliers. Well, guess what happens when you hit 70 or after 65? So, are there outliers? Yes. Suggest reasons. At 65 or 70, most people retire. Okay, and the earnings go down. Now they might be making what's called a pension. Earnings decrease. They might make a pension that's a portion of what they used to make when they were working. They might be earning money from investments they had throughout their whole life of investing in the stock market or in their bank accounts. So explain what so that's why it drops. So we see a drop at age 65 or 70 and beyond. Explain what the point 41 and 35. Okay, it means at age 41, this person earned 35,000 per year. Okay, so thanks for sticking around for that extra question. I do encourage you to use Desmos as a useful tool, just so like you use your calculator to figure out difficult math equations. You are going to use your Desmos calculator to figure out difficult graphing problems. All right, thanks for tuning in.